Good morning or afternoon, depending from where you are joining us today. And welcome to another UCAR Africa Initiative Seminar. My name is Ana del Moral Mendez, and I am part of the UCAR Africa Initiative working at the Earth Observing Laboratory here at the NSF NCAR. I will be hosting this session today here at NSF NCAR titled Utilizing the WRF Model for Short to Medium Range Forecasting at the Agricultural Research Council of South Africa. Our speaker today is Dr. Sarah Roffe, Senior Researcher, part of the Agricultural Research Council, Agrometeorology and Climate Change Division in Pretoria, South Africa. She holds a PhD in climatology from the University of the Witwatersrand, excuse me, in South Africa. Dr. Roffe's research considers climate change and variability patterns across Southern Africa, while also focusing on associated impacts. Working at the ARC, much of her work focuses on climate risk for agricultural activities. To date, her research has focused on a range of topics, including characterizing rainfall seasonality and the historical and projected changes thereof, changes and variability patterns in extreme temperature events and severe rainfall events, as well as human thermal comfort in relation to climate change. Her interest also extends to numerical weather and climate modeling, running simulations of high-impact weather events and for downscaling climate projections. Sarah, thank you so much for being our speaker today in this seminar. Just as a reminder for you, you have now about 45 to 50 minutes to present your work, and then we will allow for some questions at the end. For all of those who are joining today online, please submit your questions for Sarah through Slido. You will see a link at the bottom of the streaming website, and we will read those questions and discuss them during the Q&A session at the end. Sarah, welcome, and the floor is all yours.
Oh, thank you so much, Anna. Thank you for introducing me and giving me the opportunity to present on some of our work at the Agricultural Research Council. So what I'll be presenting on is it's kind of like it's very new work that we're trying to undertake, and in essence, we're just trying to be able to support the farmers across South Africa in more than just providing them information on like historical climate. And now we're trying to move into the realm of providing them information in terms of short to medium range forecasting timescales. So yeah, we've only started this initiative last year, and hopefully I can just share some of the work that we've done to date in this regard. So before I move on, I thought it would be important to give a background of the Agrometeorology division where I work at the moment. So in essence, we are there to inform the farmers across South Africa. And we use weather and climate information from our own weather station network to basically advise agricultural planning and just to help farmers enhance their cropping and as well as their stocking production systems. And we predominantly focus on historical timescales in terms of like 2024 and moving forward in time, or sometimes we also move into projected timescales. And this is one of our more recent initiatives where we are looking at forecasted timescales. So some of the activities that we do, we look at we focus on maybe trying to identify climate risk for areas in relation to particular crops. So we do a lot of work with maize, for instance, because much of the farming activities in terms of crops are maize. They are focused on maize. And we also look at like crop suitability, livestock suitability assessments. And we've also moved into the realm of providing like early warning, especially with regards to agricultural drought. We are now looking at some forecasting. We also look at some climate change adaptation and mitigation aspects and looking at projections. This is something we don't do as much as focusing on historical data, but it's a very important aspect. And we're also we focus on climate monitoring, and from this we try and develop different types of products and services so that we can really help out the farming industry. So this is one of the activities that we're undertaking, and this is our forecast. So, we really, in South Africa, I mean, if we have quite a varied climate, we have in the eastern parts of the country, we have quite a wet and humid and very warm climate. And then if you move all the way to the western parts of our country, we have this really dry and hot climate. And in essence, we need to be able to provide a whole range of different types of agrometeorological advisories for the farmers, because across South Africa, there are farmers in all reaches of the country. Crop farming is more concentrated across eastern areas of the country. But if we move to the western areas of the country, we have our livestock farming that is more predominant. So this is the motivation behind our forecasting system. We're servicing a lot of farmers, and we want to provide these farmers with some agrometeorological advice. So we're trying to use this forecast to essentially be able to provide farmers not only with information in a historical context, but also over forecasted timescales. So we want to complement the existing weather station network that we have. And so the whole hope from this forecasting system and our work here is really that we can advise decision making amongst farmers. Things like, when is the optimal time to plant? When is a good time to start preparing your land? When should you schedule fertilizers or pesticide applications? When is a good time for harvesting? What are some good aspects in terms of livestock management? Do we take care in terms of like very hot conditions coming, so we need to make decisions in terms of how best to manage our livestock, etc. So these are the types of decisions that we want to make, and we want to take the forecast information and provide it in a manner that's really accessible and understandable for farmers. So this is why we've really developed our forecasting system, and we want to move towards being independent in that sense, so that we can provide that information to farmers without relying so much so on the actual weather service of South Africa. So we really just want to push it so that we can have good decision making off of our forecast data. And in essence, we're using the WRF model then for this forecast. And the reason we've decided to use the weather research and forecasting model is because this numerical model, it's free, it's been applied in so many instances across South Africa. So we can already learn from many of these studies as to what are the good physical parameterizations to apply, and just in general. So we started out quite small, and we do have hopes to enhance our system. But in essence, how we focus now in this figure on the right here, we have the domain that we're using in terms of our modeling. And because we're focused really just on the South Africa region, which is the country really highlighted by the number 1 in this map, we've got quite a small domain. We focus on the oceans because we have important oceanic systems that our rainfall systems derive moisture from the ocean, so we need to incorporate these systems. We also need to incorporate systems coming from the mid-latitudes, as well as systems coming from the tropical regions. So we've tried to design our domain in a sense that that incorporates these, but isn't too big so that our forecast can run quite quickly every single day. And so at the moment, we are limited a little bit by our resources. So our forecast is not necessarily at the highest of resolutions. We have a 12 kilometer resolution grid that we're running, and we have a roughly 34 vertical levels. We run our forecast from an hour ahead of time right through to 7 days into the future, and we automate our forecast to run from 7:30 every morning. And because of our limit in terms of resources, this itself takes already some 2 hours to run. So in the future, we are working on getting better resources so that we can improve our forecasting system, better resolution, it runs faster. Perhaps we can also include like an ensemble type of system. But for now, this is our starting of the forecast. And as I've said earlier, we've only had this forecast implemented for about a year at the moment. And it's not necessarily a full data set, but we have roughly a year of data that is available from our forecast. And in essence, from the forecast, we use the WRF Python package online, and we save rainfall, temperature, relative humidity, solar radiation, surface pressure, sea level pressure, near surface winds, soil moisture, soil temperature, as well as geopotential height, relative humidity and temperature, as well, and U and V wind at pressure levels. And we save these selected variables for now, at least, so that we can develop different types of products for the farming community that we service across South Africa. And in terms of these outputs, before I move on, and I seem to have forgotten my slide, but I had mentioned that the parameterizations that we use for our WRF model, in essence, we've designed it based on previous studies. And we also did a whole bunch of testing on different types of events. So we looked at different types of extreme events. How do the different parameterizations work? If we tweak the microphysics, maybe does it simulate a cold front event better, or various things like that, just to inform us so that we have a good simulation. And I also didn't necessarily mention that we use the global forecast system data set, that the NOAA NCEP GFS data set, to initialize and our simulation, our WRF forecast, as well as for the boundary conditions of this forecast. So I covered these variables. And in terms of this, I really want to highlight how we actually use the variables and how we've started to try and design some outputs from our data set, from this forecast. And so in South Africa, of course, you know, we have quite a range of farming activities. And one of our important farming activities is fruit farming. And the fruit farming industry is quite sensitive to frost, for example. So from the outputs, we're really quite interested in looking at frost. And so far we've started trying to also validate our forecast. And what I'm showing here is really a comparative between the forecast as well as the frost extent on the 10th of July last year. And this was really, I've chosen this event because we had a rare snowfall event that hit South Africa, and it's rare in the sense that it, instead of just being confined across the mountainous areas of South Africa, it also extended right up into many of the interior areas which hadn't received snowfall since roughly like 2012. So this is quite an interesting event for us. And I mean, and what I'm showing here is the frost extent forecast that was presented for the 10th of July, and this was the day one in our forecast. And then I'm presenting the observations. And with these observations, we've just taken our weather station network, which is quite dense. It's about 600 or so weather stations over South Africa, and we've interpolated this so that we can create a surface. And in our interpolation, we also use some data products like the Error 5 as well, just to really help to facilitate a good interpolation of the data sets. And what we have here is really just comparing a visual comparison of the forecast for the first day as well as the observations. And of course it's not perfect, but we see quite similar extents in terms of frost. If you look in the northern areas of South Africa, much of this northern province, which is the Limpopo province, where you see Polokwane, the frost extent is fairly similarly replicated. And in terms of extending down to these more coastal provinces, we still see that the frost extent is well represented in our forecast. So this gives us quite good confidence, at least like a starting confidence. But in terms of evaluating this, as I'll mention in a later slide, this is still something that we've been trying to build our database before we really put together our validation of our forecast, so that we can validate it maybe for different events, like how well is it showing frost extents, for instance, or how well is it showing heavy rainfall. So the next one, I'm still focusing on this event, but I'm showing the 7th day of our forecast. And this is totaling all of the frost hours during the seventh day, because actually I didn't mention that the forecast is produced at an hourly temporal interval. And again, the output for the day 7 of the forecast is it's really quite reliable in terms of at least the extent of frost. In terms of the severity of the frost level, perhaps it's less reliable, but in terms of the extent, it's really looking quite good. Though it is showing, particularly in these southern areas of the forecast, it is showing a larger southern extent, but still it's doing quite well. Then another example, still focusing on the snowfall event, is a look at the minimum temperatures. And again, so it's showing quite a nice distribution in terms of the minimum temperatures. What we have here is the first day of the forecast, and then we also have the minimum temperatures in terms of what our weather station network is showing. And at the very least, it's showing very good patterns. So the scales are not the same in terms of the legends, but what you can see, this purple for the observations, is spanning a fairly similar extent to the yellow in the forecast, or there are some issues in some places, but the extent and the spatial pattern is fairly similar. And of course, we still have some major validation that we need to undertake. Then here's another example of our forecast outputs and how we are trying to use this. So all of these products that I'm really showing you, these are things that we're still developing within the Agricultural Research Council, but so they're not yet open to the public, but they are things that we're trying to develop so that we can, once we have properly validated the forecast, then we can at least communicate some of the uncertainties and then be able to share this with the farming community across South Africa. And we can share this in various ways. I'll present an example of this in a later slide. But focusing on this, so I've focused on the February period because we had this very interesting, very hot February, March period over South Africa, we had like a flash drought type of episode where the Southern African region was hit with really dry conditions very quickly during the February, March period over this year. And that was quite a devastating period because of that period, many farmers over South Africa and in many Southern Africa regions, their crop yields were really hit quite hard. In some places of South Africa, for the first time ever, we had to import white maize for the first time in a long time, not ever. And in some instances, in many areas where maize is farmed, much of that crop could not be utilized for sale, but rather it had to just be pushed as animal feed. So it was really quite a devastating period for us. So that's why I've honed in on this event, and it's quite an interesting one in terms of the patterns here. So if you look at the maximum temperatures, this is what I'm showing here is the second day within our forecast. And in essence, this also shows to compare quite well. If you see temperatures on the higher temperature range, you can see that the spatial distribution is quite similar across the forecast versus the weather station network, and again the interpolation of our 600 or so weather stations. And what we see is that the patterns of the maximum temperature are quite similar across higher across the forecast versus the observations. In the more northern regions of the country, we see higher temperatures, and moving more south, we see lower temperatures. In terms of, for instance, like just trying to visualize the lower temperature scale, we can see that perhaps the WRF model, the WRF outputs have underestimated temperatures in some places. So this is something, of course, that we really need to check. But if you look at here in the Durban area and moving sort of west of the Durban area, we're seeing like cooler temperatures shown quite correctly in the model, but moving more south, these cooler temperatures seem to be a little bit more underestimated in terms of the comparison with the observations. They're fairly similar, but it seems to be a little bit underestimated. But if you move around in general, the pattern is quite similar compared to the observations. So it's really, at least we know, like just from a visual inspection, we're quite happy with how our forecast is forming. Then the previous slide was day 2 in the forecast. This is now the day 4 in the forecast for the 24th of February this year. And there's a very similar pattern shown for the day 4 of the forecast compared to the observations. These higher lying areas on the eastern part of the country show lower temperatures, whereas the surrounding areas, they show much higher temperatures. And come to the forecast, and a very similar pattern is observed. And even more western regions have some lower temperatures associated with this. So visually, it's looking quite good in terms of the products we are trying to show. Then we also focusing on some of the rainfall outputs. So I don't have the observations maps for these. I just couldn't find them. But in any case, in terms of the forecast, we had this interesting flooding event that occurred in June this year due to a strong cutoff low and ridging high pressure system that occurred, and these two systems interacted, and really they caused quite devastating flooding over the Eastern Cape area. The southern province here where we have Praddock and Mthatha. And what we see is that, at the very least, in terms of the 3rd and the 4th of June, I'm showing you the first day of the forecast and for both of these days. And I'm really just showing you what we have downscaled in terms of the rainfall outputs and how we are planning to visualize and share these products with farmers for the forecast. Then, in terms of how we prepare the results and how we share some of these, I would like to share a system that we have recently started incorporating our forecast data in. This system is available to the public. And in essence, the way we are sharing and incorporating our forecast data is just really integrating it with the weather station data that we use. And basically, this is just to highlight this drought early warning system, which is one of our key applications for our forecast, and one of the key products that we already had that kind of supported and pushed our development of a forecasting system at the Agricultural Research Council. So this one is accessible, and if you would like to access it, you can go to this website, www.drought.agric.za. This can be easily accessed there, and anyone can use this information and can access this web page. But in terms of how we use the data, and so we are expanding on how we use our forecasting data, but in essence, we really just use it in terms of forecasting the SPI. And we use it in terms of just forecasting over all of these scales, the SPI over the 1 month, the 3 month, the 6 month, 12 month, or the 24-month scale. And for how we use it, we basically take the weather station data up till the latest date, and then the forecast data that we've created for that latest date and moving forward. And then we just really match these data sets and just build on the SPI from that last observed date, moving into the future with our forecast data. So the forecast data is basically treated as like the weather station data in this instance, and then we expand on it, and then we use this to provide a forecast of just of the SCI up until 7 days ahead of the time. Then in terms of our work, so that is everything in terms of the forecast, and that's really all that I'll present in that regard, because this is still quite a new initiative, and we're really trying to build on this, and we're really trying to we're really just trying to be part of this forecasting sort of initiative. And yeah, so we have long strides. We have a long way to go in terms of how we would like to improve our forecast and how we would like to go moving forward. So we really are looking at right now we're focusing on how can we best validate the forecast. So important to us is really building capacity. So we are working with a number of students on this topic and trying to validate different aspects of our forecast. So we are looking at frost, for instance, and we're looking at how well our forecast gets the severity of frost extent. So how many hours in the forecast as compared to how many hours in the weather station network. Then we're also looking at the spatial extent, and we're trying to really build on we're using the WMO sort of advice there really to their forecasting advice in terms of how to validate the forecast in terms of our validation here. So we're really trying to do as intensive of a validation as we possibly can. So far, we're really only working on the rainfall and the temperature products for our validation, and then beyond this, we're hoping to move to other types of products out of this. So for us, we really want to use this forecast to provide information on for different types of important climate indices that can inform agricultural planning. So the frost was one example, but another instance is, the forecast of very hot conditions, conditions maybe that are going to be too hot for the maize crop, for instance, and then this kind of a product would be presented really during the maize cropping season times. And then we are really hoping to perhaps try and increase the spatial resolution of our forecast. But for this, we of course need some additional resources. Our long-term goal is perhaps something, sub 4 kilometer type of scale. But of course, this will be determined by our resources that we have available. And for us, this is really, can we have high performance computing resources that is just dedicated to our forecast? Because right now we are just using a desktop machine to run our forecast, but we are hoping to gain more access to some high performance computing resources so that we can improve the resolution of our forecast. Another thing we really want to do is move on to a perhaps also extending the time frame of our forecast. So we're using the GFS data set. This has up to some 16 days of data in terms of the forecasting, and we're hoping that we can perhaps use this in the future. However, the reason we're not using it is because this really just takes up so much of time in terms of the forecast. So it's actually, we're not getting our forecast. We're not going to be able to get our forecast information out on time. So again, we just need to really wait for additional resources, which is something we're working on. We're quite interested also in coupling our forecast, because South Africa is influenced by a lot of systems which derive moisture from the oceans, and there's a strong ocean atmosphere kind of linked to our daily weather patterns. So we really want to see how we can incorporate this. We also want to bring about some ensemble forecasting as well, just to see, just to be able to get a better spread in terms of our forecast, and to just to get a larger picture in that regard. And then because we have a weather station network, and because the WRF model offers data assimilation aspects, we're hoping that we can, in essence, bring in or incorporate the simulation of our weather station records. And this is something, of course, we'll only be able to properly do when we have additional resources. And it is something, though, that we're really working on in terms of trying to figure out how to undertake this assimilation. We're lucky that there are nice tutorials online, but yeah. So this is in essence our recently started up forecast, and that is my presentation. I hope that it was informative. It was quite short, but yeah, it's a small subset of the activities that we are taking using the NCAR's weather research and forecasting model. Thank you so much.
Thank you so much, Sarah, for your presentation. It's definitely a huge step forward, I guess. Yeah, it's like definitely really important information and all the improvements that you want to do now in the future, all the steps. It feels like that you guys have a lot of work now to do.
Yes.
We started having questions on Slido. There's one question. Let's see if we can see it on the screen so everybody can see it. I don't see it. I don't know if you see it. Oh, now we see it. Okay. So there's a question saying you're currently working independently of the South African Weather Service. How do you foresee your early warnings for flooding, heat waves, and temperatures events will work alongside the official warnings being issued by the official South African Weather Service?
Oh, this is an important question because, you know, I mean, the South African Weather Service are the custodians for preparing these early warnings, and for actually officially, legally, they are the custodians and they are the official communicators of these warnings. So for us, we are not hoping to take over their role of of releasing early warnings, but we are just hoping to provide as advisories alongside. So we perhaps the better way is, you know, to see how well these can work in complement. But yeah, we do not want our we are not hoping to technically issue like any types of warnings, but rather provide advisories that can be linked and that can relate to the early warning by the South African Weather Service, particularly. So, yeah, I hope that's answering.
I think that there's a look. I'm gonna just pull one question that is also related to that. It says that they already run models on 4 kilometer scales and issue short and medium range forecasting. So how does your work link to them in that realm?
Ah, yeah, so they do run these models, and in the future, so we haven't necessarily looked at any links with the South African Weather Service yet, because it's, you know, it's still quite an early initiative for us. But what we are trying to do is just establish our plans and get ourselves working and get our forecast working. And then in the future, we are hoping that maybe we can link with them, but it's not something we've properly explored actually.
Okay, we have another question. Let's see. Since you have so many stations, are you considering methods for bias correction as a post-processing step? Example, Tmax and Tmean, temperature max, temperature mean.
Yes, yes. So our team is fairly small, so we haven't necessarily got to that, and it's probably something I should have added to the slides. But in terms of post-processing, it is something we are considering, especially once we have properly validated our forecast and really got an understanding of what is the uncertainty in our forecast, then we are hoping to add in like a post-processing step. But of course, you know, this is going to come with our resources, but for sure, yeah. I mean, from our weather station network, we collect quite a range of variables over an hourly resolution. So we've got rainfall, temperature, we've got wind, we've got solar radiation. So the hope is to be able to take all of these variables that we collect from the weather station network, and then of course start off by using them for validation, and then once we really understand, we can apply some bias correction work. I've seen a lot of interesting machine learning sort of bias correction types of approaches, and this is something that we are looking into actually in terms of a future type of aspect. But yeah, we would have to assess which is the best way for post-processing.
Thank you. We have another question. Well, we have more than one question. I'll be pulling all the questions. So for your frost forecasting and validation, are you also considering black frost as well?
So, not yet, not yet, but it is something that, yeah, we do want to eventually consider because, of the impacts of black frost on many crops. So not yet.
Okay. Following with the like the possible partnership between you and the Met official Met service. For farmers, one would need some application forecasting more than rainfall and temperature, but impact-based forecasts, such as not a good time to harvest or cover needed due to frost, like this? Do you intend to do this? Um, SAWS is already doing impact-based forecasting.
So yeah, so soils have quite a good impact-based forecasting approach that is ongoing right now. And for sure, these types of advisory messages like, okay, no, it's not a good time to harvest, or you need to cover up crops due to frost, or various things like that, then we so at the moment we are dabbling in some thoughts on this because for us to really be able to provide the farmer with this information, it is good to provide some advisories along with this. So we have not yet got the ball rolling properly on this, but it is something that will be that is on our list of like we're quite interested um, in considering this, but perhaps not in the same, maybe not in the exact same way as the South African Weather Service would be doing. Yeah.
Thank you. I don't see any more questions on Slido, but I do have a quick question. So far the information that you are giving is also through that website platform, right? That portal, or is it also through some sort of mobile application, like phone application? Like how would that information reach the farmers, and how I'm interested to know like how difficult it is to reach the local communities, and I assume that also a lot of different languages, and how does that work?
Sure. So this is something we're really looking into. So that draft website that I shared, that one is more so focused on the so it's tailored really to the commercial maize farming industry at the moment, as well as the commercial livestock industry. But of course, we have lots of smallholder farmers over South Africa. So and they're not as technologically savvy. So for now, we have the web-based application that's really targeting those commercial farmers, and the hope is to expand on that. But we don't necessarily have it um, as like a mobile application yet. And in terms of the language barriers, that is something that I guess we really need to look into a linguist or something like that to really help us out there. But in most instances, and in all instances actually, all of our things are in English at the current moments. Yeah.
Thank you so much. Um, um, there's a couple of comments on Slido. Person saying that probably collaboration with SAWS is essential for future work. I think that you already commented on that. And another comment saying, thank you, Sarah. This has been a very interesting presentation. And yeah, I second that. Like it was really good to have you here today and presenting this work. And hopefully we get to see more progress on those future steps that you are working in. So I don't see any more comments on Slido. So I think that we're gonna finish early today. So thank you very much for all of you that connected online. And thank you again, Sarah, for presenting this work with us in the UCAR Africa Initiative. This video has been recorded and will be posted on our YouTube channel for those who want to share or want to see it afterwards. Also, if you have any more questions or you want to collaborate with Sarah, just send her an email probably. She's probably going to be responding soon. So, well, thank you so much, and we'll leave it here. Have a good day, you all.